Welcome back to Databytez, your source for data-driven principles. Today, we are looking at organizational levels in data. And so, data comes in really three general flavors. We have structured data. And if you look here on my text here, we have AKA, these are known as tables or arrays. That's really what they come down to. You had semi-structured data, AKA the JSON, the dictionary, the hash map. These are semi-structured things. And then unstructured data, which is basically everything else. And so in the working world, 99.99% of any data work you're going to be doing, like on Excel or anything like that, falls in line with either structured data or semi-structured data. Unstructured data is really the realm of the data scientist, and that's where a lot of the potential with AI has really taken form. And a lot of that is converting unstructured data into something structured that can work. Really, that's where it comes down to. Things are seldomly left in their unstructured form completely. That's called pre-processing, or getting it ready for it. And there's a whole transformational pipeline for that. But again, that's a little bit beyond, but just so you understand what's going on with unstructured data, which comprises kind of like, I think it's like 98% of the data that we have is unstructured. But let's start with part one, which is tables and arrays. And some stuff might be familiar here if you remember our discussion, our videos on data structure. You'll remember the array, the NumPy array, and the traditional array and the data frame. They will look familiar. So let's run these three things. And so again, structured, meaning there is order here. There is a table of some sort. And probably one of the best ways to know you're dealing with structured data is that you do have a table. And even if I were to download it, I can download a CSV, another structured thing. So structure leads to structure. We have different ways to do it. And so we have the NumPy array. We have the regular array, which we cannot view in this regard, but we know it's just let's just print it anyway. Oh, not there. So let's print x1, which again we have here, just the typical array, how it looks. And then the data frame, which is kind of like the NumPy array. So now we have special things here. We have class. We have our dim1, dim2, 3, and 3, all ints. And we have a structure. And we can also, guess what, download it as a CSV. We're able to do that. Now, there are other structured data exists in a multitude of forms. The most common, 99% of us will deal with, is the CSV or the Excel file. But there are other things. Now, a popular file type to deal with structured data, especially when you're dealing with a lot of it, is called Parquet. And so we're able to export that out. We are able to take our data frame and make a Parquet file. Now, unfortunately, it can't be opened. At least not with anything that I have. So I'm going to try to open it. It's going to ask me what to use. It doesn't really matter what I use. I can't see it, but it's just going to be looking like gibberish, which I'm going to pull over here. You can kind of see some things going on, right? You can see column 1 indexes, name null, field name null, pandas, type, Unicode, NumPy. There's a lot of things here. Like you can see the encoding in here, but it can't make sense of it. And so you can kind of see the structure, but since I have nothing interpreted, it just looks like gibberish. But it doesn't mean that it's not structured. In fact, a great way to see a lot of more different data types, if you're inclined to play with Python and pandas with yourself, which one day we're going to cover over how this stuff works, but I really like just showing it at right now, just for demonstrational, like seeing the overlap between technologies. But here, if I put a dot and I put 2, these are all the different structured file types to the different ways we can save structured data, different file types that support structure, as well as even kind of sometimes keeping things here like metadata in order to retain some of the structural information in terms of what type should be. And we were able to see that a little bit with the Parquet when it's saying, oh, it's a NumPy, it's an object and whatnot. So we have our Parquet here, 2 NumPy, 2 CSV. I don't even know all of these. I don't know what GBQ means. HDF, that's another file. To clipboard, to your clipboard. To dictionary, because we use dictionaries to construct the data frame. To Excel, Feather, HTML. HTML has structure. JSON, which is kind of like a dictionary, but as we'll see in a second, but it's semi-structured. To LaTeX, never dealt with LaTeX. To Markdown, another kind of language. Orc, don't know what that. Pickle, SQL, again, so many different things. That's really the point. XML, we'll see a little bit about XML in a sec. But that encapsulates structured data. Again, structured data, tables, arrays. When you're dealing with an Excel, the cells, yeah, that is structured. There's order. And so then that leads us to our semi-structured, aka JSON, dictionaries, hash maps, hash tables. And this comes from USGS, the United States Geological Survey. I think that's called Geographical Survey. And this is how they keep track of earthquakes. So if you wanted to work with their data set, most often you're going to be dealing with this. I think you can download some stuff in CSV too, but I mainly see it in this form. And we have a dictionary, and you can see it has a sort of structure to it, right? But where the semi-structured aspect arises is you have dictionaries, or you have things within things, and that can go basically forever as long as you have something that can support that in memory. So, for instance, we have our first entry, type, feature collection, metadata, and the inside of that is another dictionary, which keeps all this kind of URL, title. Here, the end of that dictionary, feature, which has a list, an array, containing another dictionary, where it has type feather, and then within that, another dictionary for properties. And these are all the different properties. And you can kind of see there's a hierarchy here, so I can do that. It makes it a little bit easier to see. So geometry, oh, I didn't want to put a break here. Oh, okay. Okay, so if we were to break it down, our features have a different type, and those properties are contained here. So many different things: tsunami, zero, code, all IDs. Then geometry, we have points, and then we have coordinates. But you can see it just keeps kind of has the ability to keep kind of going. And so while there is a sort of structure there, it's not rigid, it's not enforced. So you can kind of play with it and go into as many dimensions as you need to. And, I didn't want to do that. And that is what semi-structured means. So there is a pattern, you can follow it, you can learn it, but it's not as in your face. You have to think about it more. And then finally, like I mentioned, unstructured is everything else. So think pictures, think video, think recordings, audio recordings. All of that is unstructured data. So you have to work with things in order to get it. Now, you know what? Let me go here. Actually, I don't have it here. 1 second. I think let me pause this and I will come back. So I couldn't do what I wanted, but I opened this inferred CSV in Notepad, and you can kind of see some of the structure that's here. Everything is delimited by a comma, which is again why it's called CSV, comma separated values. And it's able to be inferred. The structure is able to be interpreted by any number of spreadsheets software, in this case Excel. I'm able to pull it up here and deal with it. But the limitations arise where it's unable to store metadata. So I'm going to change some things that don't really impact the structure of the data set, but so much as the cosmetics. So I changed some things. I'm going to hit save. I'm going to close it. And then I'm going to open it again. And what happens? None of that information is saved. And the reason why none of that is saved is because, again, it is a flat file type. All it does is keep track of basic structure, structural integrity, while not actually storing any of the metadata in there. So if we're able to open up a Excel, which is not a flat file, it is something that has a lot of things going on into it. So here I have opened that Excel. And if you recall, we have these different things, tables, worksheets, and so on. Let me open up a worksheet, and it deals with file types in XML. You might not be super familiar with that, but we're able to mess with that. And this is how it looks. So let's make that. So you can kind of see, it might look a little bit like HTML to you for those people who are familiar with HTML, but also kind of looks like I think a little bit like a dictionary, except it's a little bit different viewing of it. So we have our sheet view. Go away. Really? Okay. Our sheet view. And so we're able to hide and put that in. So sheet view, again, grid lines 0. That means I don't want to retain anything about the grids. I don't want to see them. Our tab selected is number 1. Our columns, we have a minimum of 1, max of 1, with a width of 1.9. Our sheet data, so at row 1, it's a span of 2 by 4. I don't know what all of these mean, but you can see at our value here is 18. At row B1, at row 3, we have at row B3, we have a value of 12, and it just kind of goes through. So C3 is 13, D3 has 14, and you can kind of start to make sense of what this is supposed to look like in a sheet. It's interpreted. There is a structure. And if we were to look specifically at the tables, so let's go into our table things. And I remember tables are their own object in Excel. They have their own safe spot. You can see the structure becomes a lot clearer. Again, Excel likes working with tables, and one of the reasons is because things are just structured a lot cleaner. There's not as much that kind of, oh, what's going on in row here, row here. Instead of here, we have column ID number 1, name dim1, name dim2. It's able to reference and it can reference these values in a different area pointing to that, but it's able to kind of enclose it in a way with retaining the structural information. So all of this extra information is what allows Excel to be able to save things like what are you highlighting, what fonts are you changing, and it's able to store that in XML, which is truly the underlying structure of all Excel workbooks and all Excel worksheets and tables and whatnot. Everything comes down to XML. Kind of a dead thing, actually. I don't really know much besides Excel that really uses XML anymore. But hopefully that has been a bit of a informational trip down the organizational levels of data. Again, most things that you're going to deal with is structured, and semi-structured is the exotic exception. When I worked at any of the companies I've worked at, I've never had to deal with JSONs myself, or any kind of dictionary. It's always something I've made, but it's possible that you might come across it, especially if you're going to go down the data field. And unstructured is going to be your bread and butter if you want to be a data scientist. If you really want to do that, working with unstructured data is going to be the thing. And so it's different per different type of unstructured. So how you work with pictures is going to be different how you work with video. and you can conceptualize video as just a bunch of pictures together, stringed really fast, which is again different from audio, which I don't even know how you deal with audio. Or it could even deal with something with like radio waves, like signals. And so dealing with signals could be something else that you're dealing with. There's just so much unstructured data that it really makes the bulk of what we do with data. And it's what sparked this revolution in AI, like ChatGPT. Anyways, I digress. That has been it for today on our discussion on structured data. I hope you have a great rest of your day. As always, it's Patrick from Databytez. Stay data driven. Have a good one. Bye.